Let's take a look at the following quadratic inequality. We want to solve for x squared plus 3x minus 28, and this is a problem from section 3.6. Now notice we have an inequality symbol right here, and what we are asked to do is the following. Take the quantity which is on the left, which is x squared plus 3x minus 28, and make sure that it is positive. So we want a sign of plus, a positive sign when we're looking later on at a table. For which x's is that happening? Now, since we do have a 0 on the right hand side, that's a good thing. So we're going to proceed in this following way. We're going to go ahead and factor the left hand side. Just keep in mind, if you are provided an inequality without a 0 on the right, you need to do whatever steps you need to have in order to get that 0 on one side. So I'm going to go ahead and factor the left hand side and still want this quantity to be positive. To get an x squared, we need an x times an x. To get two numbers placed after each of the x's in the parentheses, we need to find two numbers which product is going to be negative 28 and which sum is going to be positive 3. So if you think about it, you're going to need the numbers plus 7 and negative 4. So the question is still the same. We do want the quantity on the left, whether we call it x squared plus 3x minus 28 or x plus 7 times x minus 4. We do want that quantity to be positive. So this is the expanded form, x squared plus 3x minus 28. This is the factored form. We're representing the same quantity in both instances, and we want those two quantities to be what sign? Positive. And notice it's a strict inequality. It's strictly greater than 0. We do not have an equal sign. Okay, so keep that in mind. We'll have to remember that later. So in order to solve this inequality, whether it's written in factored form or not, what we notice is that we have to go ahead and find some special numbers which are called boundary points. How do we get those? What we do is we temporarily replace the inequality symbol with an equal sign. And let's use a factored form since we're trying to find the values of x that makes the expression on the left equal to 0. So a product in math is 0 if either the first factor x plus 7 is 0 or the second factor x minus 4 is 0. Solve those two simple equations for x and you get two values of x that cause this to happen, and they are x equal to negative 7 and x equal to 4. Those are called boundary points. And let's recall what the boundary points do. That negative 7 and that 4, they cause the expression on the left to be equal to 0. And let's recall also that in the end run, we do want the quantity on the left, that x plus 7 times x minus 4. We want this quantity to be positive, strictly positive. There's no equal to 0 in the end. So keep that in mind, just strictly positive. So let's go ahead and proceed by noticing that those boundary points are going to split up the number line that runs from negative infinity to infinity into 3 test intervals. So let's see how we're going to proceed. We're going to draw the number line that runs from negative infinity to infinity. We are going to locate our boundary points, negative 7 and 4 on that number line. Make sure we put them in order. So we'll put negative 7, more to the left than 4, just like they should occur. And notice that those two boundary points are splitting the number line into what we call some test intervals. The first test interval will run from -infinity to -7. The second test interval will run from -7 to 4, and the last test interval will run from 4 to infinity. Now, keep in mind I use some parentheses on purpose for those test intervals. We can always at the end decide whether or not we want to use a parenthesis or a square bracket on the values -7 and 4, or on one of them. So let's go ahead and take a look at what we have. We're going to organize the tests that we're going to use on each one of those test intervals in a nice table. And keep in mind, what are we trying to do? We're trying to find the x values, which intervals will satisfy the fact that the quantity x squared plus 3x minus 28, or also called x plus 7 times x minus 4, we're going to ask that this quantity be positive. So we need to go ahead and organize our table. So for my table, I'm going to have a column over here to the left, and the first heading will be test intervals. And what are the test intervals that we have? We have the green test interval from -infinity to -7. Then we have the blue test interval, which runs from -7 to 4. And finally, we have the red test interval, which runs from 4 to infinity. Now, we need to check the following. That for any value that we pick in any of those test intervals, we want to know the sign of the quantity x squared plus 3x minus 28, also called x plus 7 times x minus 4. But keep in mind that within an interval, within the green interval, let's say, whether you pick a value x equal to -10 to check that interval, or x equal to -9, or x equal to -8, or x equal to -1 billion, any of those x values will tell you the same information about this expression over here, whether it's positive or negative. So you just pick any x value in the green, test interval, and that will give you the information about the sign of that expression, whether it's positive or negative throughout the green interval. So that's what we're about to do next. We're going to go ahead and in the next focus over here, we're going to think about what we call a test value, or over here, what we call a representative number. It's a representative number. Okay, I'll just put number like that. I don't have much room. So what do we pick for the green interval? You can pick anything you want. How about I choose x equal to -8, okay? And usually we don't bother saying x equal, it's just imply. I just put -8 is my value. Okay, then what value would I pick for my blue interval? For the blue interval, let me pick the following test value. If it's not a boundary point, it's always pleasant to plug in x equal to 0 as a test value. So I'll pick 0 here for the blue interval. And for the red one, you could pick x equal to 5, x equal to 6. It doesn't matter. How about I go with x equal to 6? Okay, you could pick x is, 100. That would still work for the red interval. Okay, so let's go ahead and do the following next. Let's take a look at what we have in mind by picking those values. We're going to do the following. We're going to compute the sign of the quantity, and let's write it in factored form because it's friendlier, x plus 7 times x minus 4, or if you wanted better, or the quantity in expanded form, x squared plus 3x minus 28, which is a little bit more work. So we're going to compute the sign for each one of those test intervals using the test value that we selected. So what I'm going to do is the following. I'm going to pick x to be -8, and I'm going to replace that particular value of x in this factored form over here, this product. Instead of x, I'm going to put a -8, and I'm going to see what sign those two parentheses will have. So I put a -8 for x in both of the parentheses. Leave everything else alone. And what I'm saying here, I'm saying that in the first parenthesis, I have a value which is -1, but all I care about is that that value in the first parenthesis is negative. So I have a negative, quantity in the first parenthesis. In the second parenthesis, I have a value of -12. I don't care about the 12, I just want to know it's negative. So I have a product of a negative times a negative. And where this is leading, let me just finish up with this one just so you can see what I have in mind. In the next step, we're going here in the next row over here, we're going to have a conclusion about the sign of the quantity x minus 7 times x plus 7, let me say that again, times x minus 4. Also, it's the same thing as saying the sign of the expanded form x squared plus 3x minus 28. So just so you know what we're doing next, in the next step over here, what we'll have is the following, is we will conclude that having a negative times a negative will give me a positive, and that's for the interval, that's the green interval. So the quantity x plus 7 times x minus 4, also called x squared plus 3x minus 28, is positive on that interval. So that's where we're going with this. So for the second test interval, notice we're going to use the value of x being 0, and I'm going to replace in both of those, put a 0 for x and leave everything else alone. And I want to know the sign of those two parentheses. 0 plus 7 is 7, so it's positive, times 0 minus 4 is -4, so it's negative. So for that particular test interval, the blue test interval, then the quantity is going to have a sign that is negative. Let's do the same for the last interval. So for the last interval, we're going to go ahead and replace the x value by 6. So anywhere you have an x, you need to put a 6. So instead of x, I put a 6. So I have in the first parenthesis, I have 6 plus 7, which is positive, and 6 minus 4, which is also positive. So the product of those two will give me a positive. So let's just keep in mind what we have to do now. Remember, we were trying to find for which value we're solving for x. We're trying to find the value of x such that this expression, also written in factored form, as what sign is positive, strictly positive. Okay, we don't want it to be 0. Let's remember this quantity right here, also written this way, was 0 for x being -7 and x being 4. So the way we finish up this question, we want the quantity to be positive. So we like this, we like that. Therefore, we like the two intervals involved, the green one and the red one. So the solution set is involving the green interval and it's involving the red one. Now, what do we do at -7 and 4? So just to show you a little bit, if you were to evaluate the two quantities right here, those two, when x is 4 and also when x is -7, you would see it doesn't work, as I'll show you in just a second. So notice that if you were to replace x by 4 in either one of those inequalities, 1 or 2, you would get a false statement.